great book by Azim Azhar, The Exponential Age, really gets at a bunch of technologies and how they're impacting society. And Azim's main argument here is to say that there's a bunch of technologies that grow exponentially, a bunch of organizations that grow exponentially with them, and then there's the rest of us. And the rest of us grow linearly, right? And that creates a massive gap, right? We're feeling this gap today in many of our organizations, right? So I keep telling the dean, he doesn't listen to me, right? Our biggest competitor is not Stanford or MIT or Wharton or Chicago or whatever, right? They're irrelevant to our competitor set. Our competitor is LinkedIn Learning, right? With 300 million people on LinkedIn Learning alone. We have 300 million people, right? And so it depends what game you want to play. There's a set of companies that are playing in this exponential game, and then the rest of us that grow linearly, and that creates issues for all of us. And that's what let's just think about this in terms of how do we contextualize this AI era, okay? There's been about 4 waves of AI. Between the first and second waves, there have been these AI winters. There was an era of cybernetics, okay? Then trained experts, expert systems, some of you may remember. Then what started in 2000s out of Google, Facebook, Amazon, and so forth, good learners. Lots of data available, breakthroughs in computation, breakthroughs in algorithms, and we started to use machine learning without knowing it. So when you use Netflix, you were using machine learning. When you were using Waze, you were using machine learning. When you were using Amazon, you were using machine learning. But it was in the plumbing, right? 20 years of that, amazing progress. That was the system that basically built the next Rembrandt. And today, we're in this generative systems wave now. Okay, generative systems, and we'll talk more about that as well. All these things converge, and then the interesting thing is that the application space is jumping across the board. So the same technologies that have sort of enabled these image diffusion models, right, are also helping us find better proteins. Okay, it's exactly the same technology, right? So this is my colleague Armin McRachin at Flagship Pioneering. I spent a bunch of time with him thinking about AI-first companies in life sciences. And this is like, he uploaded his image and got all these nice avatars come through. But the same technology enables brand new protein creation that have never existed before, right? Reinforcement learning and the core technology, right? AlphaGo, amazing, right? Helps us really understand what's going on within the context of exploring the chemical landscape. Again, that would matter for a pharma company. And then similarly, large language models, which we'll be talking about. Again, you can read the entire literature, figure out different ways to go after things, okay? So definitions out in the literature. The left one is about science fiction, right? So far, right? Which is autonomous beings doing their own thing. And the right definition, which is known as strong AI, the right definition is all about any activity computers are able to perform that humans once performed. That's it. Super simple, helps us figure this out. The book that I wrote with Marco basically said, look, we can't just be about technology, right? Even though I'm in the technology and operations management group, it's really about its application in business, right? So I tell the dean, when one of our guest alum, Stephen Schwarzman, gave a ton of money to MIT, right, to set up the College of Computing, there were like lots of long faces here, like, oh my God, how could it be, blah, 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 blah. And I said, it's the best news ever for HBS. Maybe not so much for Harvard, for HBS, though, because all of a sudden, MIT is going to take care of the technical labor. They're going to create all the boffins we want that understand this stuff, right? And all we need to do here at HBS is to get our students and our alums comfortable with what's going on and think about its application and make a ton of money and have a good impact, too. I was like, it was super clear, like, come on. What we see is that there's 3 vectors now. Right? When you guys were on campus, we talked mostly about the left side, product value. Okay? Well, how good is the product? How well does it work? The fit and finish, blah, 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 the functionality, right? But what also matters now is the network value, the ecosystem value, right? Network effects, but also the data value. So these 2 dimensions have become super critical, and that's how Ant thinks about the world, right? Their value creation is about product, network, data. The operating model, which is near and dear to my heart because, of course, strategy guys can talk strategy all they want, but if you can't deliver value, good luck, right? We want to think about scale, scope, and learning. And at Ant, it's a very different architecture of their data, very different architecture of their enterprise, right? Different set of capabilities, different set of technology assets. And these differences are salient, and I'll show you some data about why that matters, okay? And most of us are living on the left-hand side. At Ant, right, the idea is that you basically remove human bottlenecks and you substitute with machines, okay, and AI, right? And this code from Satya Nadella predates all the Gen AI stuff he's been doing now. It's really about AI is the near runtime that's going to shape all that we do, okay? And the idea is if you substitute technology and processes driven by technology instead of by people, then you're approaching zero marginal costs, right? Just think about, when you search on Google and there's an auction, there's no humans doing the auctions. When you are getting a recommendation for your Spotify playlist, there's no humans giving you that, right? That allows them to go scale in this way. Basically is the more data you get, the better algorithms you build, the better algorithms you build, the better service you have, the better service you have, the more usage, and so on and so forth. That's the flywheel you want to be in. And that's what these companies do really well, especially Ant. Okay, but the core part, though, of Ant is what we call an AI factory, okay? The AI factory is what systematizes analysis and prediction at scale, okay? Most organizations have lots of investments in AI and analytics and so on and so forth, but they're mostly craft-based organizations, right? They're organized as craftsmen, delicate models. You want data, okay, meeting, to get access to the data in the company. Oh, let's get the lawyers in because we don't know, which tech companies have been able to pull off. And so in traditional operating models, we sort of see the same concerns of scale, scope, and learning, and we learn from many of these organizations how to do this, right? And the solution that was invented in the last century was to basically build a divisional system, right? Be focused, get the thing done, right? The divisional system created a ton of value, right? Our modern built economy has been based on the divisional system. But the problem is that it doesn't scale too well when the demands on the number of users you want, when the demands on the scope you want, when the demands on learning increase, right? You basically have this concave curve that shows up, right? It peters out, right? And you live this, right? Complexity of the operation complexity, administrative costs, just inertia. When we think about companies that are digital first, AI first, they have near zero marginal costs, and they put into play network and learning effects, right? What we talked about before, right? So think about this as a network effect. The value of the product or service increases as more and more users use it, right? But then what AI does is that it supercharges this curve and makes it way more sharper. That's why we're sort of seeing these crazy valuations. That's why we're seeing this crazy scaling come through. And so then you remove the traditional constraints. Scale is about zero marginal costs and network effects. Scope is about modularity across markets, right? And learning is constant through ML and AI. And this leads to collision. This leads to collision between two distinctive models, right? The one that can scale exponentially and the one that has convexity, concavity in this way, all right? And by the way, this picture is also the picture of our lives from 2020 to 2022 and a half or something, right? An exponential disease process called COVID, exponential, right? That's why we had to do social distancing so that we wouldn't infect each other, okay? With fixed hospital capacity. So the whole world learned about the dangers of AI, not AI systems, the danger of exponential systems. It's just that this has been happening over and over again in a range of industries as well, right? And so what we see is that my dear colleague talked a lot about disruption, and that's still going on, but we also talk about collision. You have collision of business models and operating models, right? And you basically have a concave system with a convex system colliding, and then once a system achieves exponential growth stage, it's really hard for us to pull that back. Now, lots of fun it does. Okay, 1 to 2 million new clothing designs per year translates to 4,000 new SKUs per day. 4,000 new SKUs per day get launched. Okay, the traditional fast fashion, Uniqlo, H&M, Zara, right? 20,000, 40,000 SKUs, right? Order of magnitude, several orders of magnitude difference. Okay, time from design to product, 3 to 5 days, right? 14 to 60 days. Minimum order size less than 100 versus about 10,000 and up. Very different economics. Okay, It's a two-sided platform, as Ray said, right? You, on the one hand, you accumulate customers, you create a very social environment, digital marketing, trend-based, lots of engagement on the platform, okay? But then on the other side are 6,000 small and medium-sized manufacturers in China that can make stuff to spec, okay? So their ability to say, let's go get a shirt designed, right? Using AI for design the shirt, get the shirt designed and manufactured, put it on the product spec, see if there's a signal, if people care about it. People care about it, let's go make some more, okay? And that Marco saw. The two factors are causally related to returns between the ones that are doing really good versus doing really bad. The technical architecture and the processes that enable them. Okay? Those are the two factors that basically drive the difference between winners and losers in the ones that invest in digital transformation and make it work. And we've done all the econometric tricks to be able to go get at that as a causal arrow. Okay? And what it looks like is when we did the analysis, the laggers look like this. They're behind in terms of returns compared to the leaders and also the total enterprise value growth. Their systems look like this. Are these familiar to you? Yeah. Okay. So this is the work. But by the way, this is not just an architecture diagram of the system. This is also the organizational diagram as well. Right? And all of these intersections are all the meetings that keep happening over and over again. Right? There's lots of entropy here. Okay? And the leaders look like this. Right? And what's nice about this data is that we're not actually even sampling on the crazy tech firms. We're looking at existing firms that are driving the transformation. So we see return value, and we see a causal relationship between changing your architecture, your technological architecture, and your organizational architecture and your processes. And the ratio, I feel, is like 30-70. 30% of the work is heavy lifting and technology. 70% is all, unfortunately, lead. Right? It's all OB. It's all change management and process management. 70%. Again, as a Tom professor, I'm sad, right? I've got you the most brilliant thing, fix it. But no, like apparently people matter. And we got
fundamentally goes against the ethos of curiosity and learning and actually voicing your opinion and potentially being wrong, but provoking that debate. Where I think this actually could be helpful is after you have the class, then you can say, oh, what does the bot actually think? And I think in the long run, why it's dangerous is because you can come down to an intellectual conformity, right? Like these are all very smart answers, but if everyone has the same answer, then where's the ingenuity and the whole ethos of the case study method to try to tease out those extraneous thoughts that can provoke really interesting conversation?
Yeah. So what should we do? Sorry, keep the mic. I have a question for you. What should we do? Like, should we ban this? Like, just like tell the students?
Well, that's why I was taking the classic bridge approach, which was I think
but do you think students will really say, "Yeah, Grandpa, sure"? Like,
no,
okay.
Of course not. They're HBS
I'm gonna
students.
wait till after
you guys are screwed. Thank God I'm old.
Yeah.
But I think where it's helpful, genuinely, is ex post facto, perhaps in the last portion of class, and then you can say, okay, if you take the kind of, not that HBS students would abide to this, but like a pseudo business school Hippocratic oath, where you're like, you cannot
if your future selves aren't going to do this, then we're screwed, right? You just said like the students aren't going to follow.
Some of us would, some of us wouldn't. I'm just.
So then are we going to create a divide between those that have the technology and know how to use it versus those that do?
No, I don't. I think it's pretty easy to use.
Yes.
Right. So I think.
So should we have a prompt engineering class at the beginning of MBA? Here's how to ask questions of ChatGPT.
Oh God.
But do you see the problem we're in? Do you see the problem we're in? This is like an existential question to us now, right? And we're working like mad to try to figure out how to answer this. There's a hand, but you see, like it's like I woke up and I'm like, we are, bleeped, right?
So I'm interested in this notion of hallucinations and
yes.
Just.
Okay. side is the people that are super smart. We think that all of us are on the right tail, right? And then there's a left tail. The question is, how does AI impact this distribution? Okay? Conventional economic analysis was that the left tail is screwed, right? The repetitive, boring jobs are going to be done by AI, and it's game over for them. I think something interesting is going on, especially with knowledge work. Because now what you can imagine is that the whole distribution shifts to the right and gets narrowed, right? So I was talking to David Autor at MIT, he's an economist there, and we're exchanging thoughts. I'm running some experiments about this in a couple of companies, consulting companies and so forth, around this. And what we are seeing is actually something very interesting. So what David said was, look at healthcare workers, right? Nurse practitioners, right? There's a study that just came out a month ago that showed that ChatGPT is better accuracy than doctors and more empathy than doctors. Better accuracy and, right? Because like, if you see this distribution, what do you call the person who graduates the last of their medical school? Doctor, right? So now all of a sudden, nurse practitioners could use this tool and be really good, right? Think of the law firms, paralegals, same thing. So we're seeing this shift happen, and this is actually kind of amazing. And then, okay, so I'm over time, so I'm just going to share with you. We've got this great institute; it's incredible. We're doing cool things. We've got lots of labs. We've got all these cool labs. I have no time. Anyway, we got like labs on fintech, crypto, Web3. That still matters apparently. Lish and AI, data science, right? Reskilling, value, trustworthy AI, digital emotion. You name it. We got amazing labs, amazing faculty working with us, both from HBS and also from the engineering school and from the medical school. Great set of initial faculty. We're going to be growing our labs over time. We're basically trying to build a Broad Institute model for research here at HBS. Okay, and some insights. I like this really amazing paper. She showed you can do market research without the market. Using large language models, you can basically replicate and get economically sufficient answers from ChatGPT. 3.5. Right? Great paper. I'll send you a link so you can get this paper later. Okay. We had two of our executive fellows really focus a lot on what it means for startups, right? And again, they're showing that AI startups are seeing 50% higher top-line revenue than the peers, and then talks a lot about what you need in terms of the teams as well. That is a mailing list.